Thanks for coming, first of all. And I'm going to be talking about building top-notch SDKs. My name is Hugo Domenech, and I work at Relayer as an Android developer. I come originally from Spain, but the whole company is based in Berlin. And I'll be explaining my experience building the Android SDK for the Relayer platform. So first of all, if you are bored or you want to tell me how great the talk was, you can tweet about it. Here you have the hashtags and the about the Droidcon and the people involved. And I want to explain what Relayer is, because in order for you to understand why we built an SDK, I think you first need to know what are we building an SDK for. So Relayer is a platform for the Internet of Things. We want to be able to connect anything to our platform and be able to interact with it. Our motto is bring things to life. And for that, we couldn't just start asking people to integrate things. We needed to ask to make it easy for people to integrate things. So that's why we created something called the Wonderbar, which is a really easy prototyping tool for anyone to start playing with for anyone to connect things to the internet and also to make things smart. It's based in a chocolate, so it should be as easy as chocolate to use. It has six different sensors. It's temperature, humidity, iron transmitter, sound, the growth, which is my favorite one, where you can connect any other devices. Then you have an accelerometer and gyroscope, and the light, color, and proximity. So our SDK, one part is to connect to this piece of hardware over BLE, and we abstract all that. And the other part is to connect to any device over the cloud. So an example, like why would you use this, is this Insulin Angel. A company just launched it in Indiegogo. So are there any diabetics in the room? Well, so this is basically a thermometer that you put with your insulin. So diabetics need to pump insulin like at least once a day, every day. And the insulin, whenever it goes too cold or too warm, it goes bad. And if you pump it, it can be that it hurts your body or it doesn't do anything. So you need to know if the insulin, you can still use the insulin or it's bad and you need to use a new one. So they are trying to solve this problem with this thing that is the Insulin Angel. And they used one of the sensors from the Wonderbar to do it. And this is how it looks like. It's just a casing for the sensor. So once we know a little bit about what Relayer is, let's explain why we built it an SDK. So the agenda for today is why we built an SDK. Then we will be talking about how we build it, and finally about what are we doing. So let's start with the why. So when we started with the Wonderbar, we didn't have any tools to really get data out of it. So we started to write the BLE services. We started to create an auth procedure to connect to our cloud. But and we did a few examples, and it was great. But suddenly we started to do more and more different demos, and we realized that we were repeating a lot of code, and that it wasn't really easy to start a new project. So that's the first point. So we wanted to make it very, very, very easy for anyone to start writing applications with a wrapper to our platform. We wanted to abstract all the things related to our platform, we didn't want to expose whether they should do an HTTP call, or they should be using BLE, or they should be using a WebSocket or MQTT. We wanted to have this in the background and just make it really, really, really easy for anyone to use it. That help us build better software by separating concerns. So we have now several modules which are just dedicated for one thing, which is great because at the beginning you just start with a huge code base, and then you can really separate things that are specific for solving one problem. And another reason why building an SDK is to apport some branding to your platform. Anyone could be doing things very differently, but we want to provide a consistent experience across all the relayer devices or across all the relayer apps. So so once we had all that in mind, we wanted to share this knowledge, and the best way to do that, we thought, is to make it open source. So we wanted to be transparent, and we wanted to that anyone could learn about our platform. So everything that we do is open source. Both all the SDKs, the hardware, the firmware in the Wonderbars, everything is there for anyone to see. And I think is a very powerful technique for both you and the community. For yourself, it makes you feel better because you are contributing to the Android ecosystem. It's not just that you do something for yourself. It also helps you to code better because you know that you're going to be publishing it and people is going to be looking for that. So there's this thing called power of shame. So you don't want to put anything there that looks horrible. You want to really do something nice. It's also easier to sell if you show a piece of code that is well written. It's an extra reason for you to use it. While if you just see a black box and you don't know what it's capable to do or what's behind it, you might decide for something else. Another reason is if you get successful enough, you start getting things for free. You start getting bug fixes, or you start getting new features and new feature requests. And that's also a very powerful technique to sort of grow faster. Also security, you just don't put all the passwords and everything inside your code base because that's a bad practice, but you might do it if it's closed source because you might think that this is the right way. But by putting everything out there, you force yourself to think more about security. Another reason, because it's free. Like, it doesn't cost you anything to open source it. You just need to create a repo somewhere outside and let people use it. Another thing is, well, actually, the most important thing is you as a developer. You want to be famous, right? So this is the only way we have to sort of put our name out there. And this is what we did. So if you go at Relayer Android SDK, you can see a real example about how an SDK has been built. Of course, there might be some things that you like more and things that you like less, but that's why we did it as well, so that we can hear feedback from anyone. And if you think that something should be done differently or better, just make a pull request, and we will try to change it if it makes sense for us. So now that we discussed why we should build an SDK at all, let's continue with the how. So first of all, you need to decide what you are providing. There are several ways that Android and Java has to provide libraries. So the first one is a library project, which this is the old way, which is just you download the source code and you include it in your code base. This is a bit ugly, and it was the only way to do it when Eclipse was around, and this doesn't allow you any source control or any versioning. So it's really easy to add it, but once you want to get the newer version from a library, it's really hard. So another option is having a jar. This is a normal Java library. it doesn't have anything from Android, so this is a great solution if you want to provide some functionality that doesn't have to do anything with Android. So if you want to do an HTTP client or anything that is Java related, this is the way to go. Then APK lib, this is an old format. This was an effort from the community to bring this library project into Maven. So it's basically just a zip file of all your classes and your resources, and that was uploaded to Maven. But this was a community effort to sort of make it easy for developers to use different versioning. But then Google got into the game, and they released this new format called R, which stands for Android Archive Resource, if you are the kind of people interested in knowing that, which is basically the same idea, but is the standard way of doing things now. And it's really easy to just include it as a user to just include it in your project and have some sort of versioning. And I'll talk about that a little bit later. So once we had that, we said, okay, let's build an SDK. We know what we were providing. In our case, was an Android library because we were accessing things from the phone. I mean, an Android AAR. So we were accessing functionality like Bluetooth Low Energy. So we couldn't get away with a jar. So that's why we did it. So then we said, okay, let's create an SDK. So how do we start? Creating a project in Android Studio, right? No, that was our first thing. So we didn't want to start writing without really knowing what to do. So we started with the documentation. We hired a full-time person, which her title is Documentation Hero, and the idea is that she will drive the experience of of using our SDKs. So she will write things as a user. So how is it easy for her to sort of get started with our platform? And the idea is to let the world know about what you are doing. So I'm not saying that you should hire a full-time person, but it's a very important thing to have in mind when you are creating something. You want to let the world know what you are building. The second thing is put it in GitHub. Like, it doesn't. Once you put the documentation, it doesn't do anything in your computer. Just you can access it. So put it in GitHub, even if you don't do it open source, because you are gonna work with other people, and they are gonna have to get this code. GitHub or any other source control, for that matters. Then you want to build it with Jenkins. At the beginning, it won't build anything because you don't have anything, but it's the best time to do it. So the idea behind that is that it works on my laptop. It's not the way to go anymore because it might be that that it doesn't work on a laptop, or that a person has a different configuration and you hard-coded something. So the best way to start a project when you don't have anything there yet is to put it in a CI system. Then it's time to add some tools. If you want to use some lint or other tools, it's now the time or some formatting tools. It's now the time to put them. Now that you don't have any code, because if you put it at the middle of the project, you're gonna have a lot of issues. You're gonna have like thousands and thousands of warnings and errors, and it's gonna be really hard to refactor at that point. And you might introduce bugs. Then think about adding in-code documentation. This is more for developers. This is more for specific parts of the code. The easiest way and the traditional one is having the Java doc. might also need to add a task in Gradle to configure that. You can take a look at our SDK. We have there a nice script that just generates it and publish it. Then the next thing you have to think about is tests. In Android, always has been really hard to sort of start using tests because you need to add, there wasn't a very standard way to do things, so maybe you had to try this library or this other thing to make it working. So, and if you have, again, if you have a lot of code, you don't want to start doing that at the very end. You want to start that at the very beginning. This should be your first thing. And then it's time to publish to Maven or 20 other places that people can pull your code very easily with just adding a file in your Gradle file and just adding a line in your Gradle file and being able to use it very easily. And then once you start coding, you need to provide an example. An example is the easiest way to let people know how to use your SDK. So this is it. Then you start coding, and once you have the first functionality, you want to test it, right? You want to start managing what we call releases. So what we like to do in our project is to use our library or the SDK that we are building in a real project, because it's the only way when you're gonna be able to test it in a lot of different devices. So we like to ship first our app with the SDK inside, and then gather feedback or gather if there are crashes or something is not working properly, and then before we publish a new version. So the way we do it is we have 3 branches. Usually we follow the GitHub flow. So we have master, develop, and a feature branch. Master is pointing to the Play Store. Develop is for our internals in the company, so friends and family, basically, for beta testers. And then feature branch is for us to sort of do new functionality. And we mimic this in the SDK, and we include the SDK as a sum module to be able to test a feature. So for instance, if we want to add new users to our app, we create a branch called new users, and then we do the same in the SDK. So we mimic the structure, and once both are ready, we're able to publish it to the next level. So once a feature is ready, we put it in both branches, both in develop, and we try with the people in the company, and if it works, we put it in the Play Store, and if it works, then we publish the SDK. So now that we discussed a little bit what are we providing and how to provide it, let's talk about the what. So what are some great qualities of an SDK? So first of all, it has to be available. We talk about that. It has to be public somewhere, otherwise no one is going to be able to use it. It has to be easy to use. It doesn't make sense if it's harder for you to write the code yourself than to use an SDK or a library. Like the library is basic. It has just this. The reason of a library is to make it to make it easier than to write the whole code that you would otherwise. But it needs to be flexible. It doesn't have to just let you do one thing, but it needs to let you do several things, and for you to be able to extend it and not just do the thing that the SDK developer was thinking about. It has to be testable. So if you have an app, if your SDK is wrapping some web services and you want to do unit tests in your app, you need to be able to mock the SDK, or you need to be able to debug it, to run unit tests without hitting the real APIs. You need your test to be deterministic. So you might want to provide a mock mode or some other things so that it doesn't take longer for the unit test to run. Um, it needs to be performant. It shouldn't slow down your application. It needs to be reliable. It shouldn't crash all the time, basically. And it should be lightweight. We all know about the 64,000 limit method, so you shouldn't try to do a monolithic application that covers all Android development. It should be a very specific and target tool. So let's talk about availability. This is how you use Gradle to include our SDK. This is a usual way to do it. And you're probably familiar with that. But what you're not familiar with is, sorry, how you publish to Maven. There are other repositories, as I said, but we use Maven for publishing our artifacts. So we follow this script from Chris Baines, which is very, very simple. You just need to define the two plugins that you're using, and the most important part is to define the group ID and the artifact ID, and then get the version name would be the version number that you defined before. And then you need to provide some authentication for your repository, and this will be in a separate file that won't be included in the repository. Then if we scroll down, we know that we need to provide some information, so the packaging type and where to find the SDK, if you have a license, which one it is, and also who was involved. And then you need to provide other tags, which are signing and right after signing you need to upload the files, but you also need to the two artifacts are these two, the source to get the sources and get the Java doc, and we want to push them at the same time. So what we do is we provide the sources, and then we create a Java doc with a custom task. And then we publish it. And then after an hour or so, it's available for anyone to use. So once it's there, you want to start using it. And for start using it, you usually need to initialize it. So how do you do that? There are basically three options. If you need to initialize it, like your library or SDK might not need an initialization, but if you're using auth, which is an authentication mechanism, you usually need to provide three things: the app ID, the client ID, and the client secret. So how do you provide these things? There are basically three ways: as a Java code, some sort of initialization method, as an asset. So in your assets folder, you can provide a properties file that the SDK will grab whenever it's used or needed, and as metadata in the manifest. These are basically, there's none that is better or worse. We use a Java asset because it's very easy to just download it from our website and include it in the project without you needing to change any files. But you could go any other way, and we didn't want. So if you're building a Java SDK, it's also the way you should do it, or either that or in the Java code, and putting it into the manifest is the Android way, but it's not better or worse. It's just a different way. So if you really like to define everything in the manifest, this is how you would do it. So we said that it should be easy to use, and that means it should be intuitive. You shouldn't think too hard about what you're trying to accomplish. It should present to you. Should be consistent. So if you are sometimes getting things with a get method, you shouldn't then say fetch or request. You should try to keep the naming consistent. And it should be easy to use, but also hard to misuse. That means one method shouldn't really one method shouldn't, for instance, have a lot of arguments because then then you could do it. It could be confusing for you. So let's talk about the easy to use. So you want to. So this is a way, right? You are creating an SDK, so you just create a new class, you pass your context or whatever you need, and then you log a message or do something with it. Do you see any problems? It looks pretty simple. The only problem is that then you need to keep the object all the time in memory. You need to pass it around, and this might be a bit complex for some users, or you don't want any users to be worrying about that. So another option is to have some sort of singleton or have a main class where you access all the time, and then you can log messages accessing this class. But there are also some problems, which are that once you are if you are doing some API calls or something, it's very hard to mock, and you cannot. It's not testable either. So the approach that we follow is to use the builder pattern. So we provide all the dependencies that we need at start time, and then we continue with the code. So we said that it should be flexible. That means your SDK shouldn't force you to use a lot of features. It should just, if you want to use one particular thing from the SDK, you should just use this particular one and not everything. So minimize permissions. And the way to do it is checking it at runtime whether the permission was added in the manifest. Also, you need to minimize requisites. So imagine that the user wants to use Bluetooth, for instance, but the device doesn't support it. So that would exclude the Bluetooth, this particular device. But we don't want that. We want the app to be available everywhere. So again, you can set up the user's feature as false. That means that is not required. And then in your app, you just check again at whether it's supported. It should support different versions. Like we know that not everyone uses lollipop, so you should specify a minimum version and the target version, and then at compile time, like really check if some feature that you're providing is available. You might want to run the SDK in a service, so or in a context where there's no UI. And a way to check if there's a UI is registering on the application creation for activity lifecycles callbacks. And if this has never been called, you know that there's no UI. We said that it should be testable. So it shouldn't make API calls when you want to run unit tests. So a good way to do that is providing a mock mode, where you just provide some mock data from inside the project. Avoid static methods, also because they are not mockable. And avoid final classes because you cannot extend them and provide different functionality for your test as well. We said that this should be performant. So imagine this API call that it gets devices, but this runs in the UI thread and is blocking. It's a blocking call. So this will freeze the UI, or the user will have to will have to handle the threading itself. So that's not a really nice user experience. So there are alternatives, which are providing a callback. The get devices itself doesn't return you anything, but you return the value inside a callback. Or the new fancy new way is with observables. You can use it with Java or do them yourself. And you basically subscribe to the changes at some point in the feature. An example, so this is the first way. You get the devices, but this will be broken in the UI, so you might need to do it in a thread. in this one, we handle all the threading ourselves. And then the third way, you need to subscribe to get the devices. And here you can specify in which thread you are running or in which thread you want to get the devices, and it's a more powerful way. Also, avoid debugging in production. I mean, there could be a whole new talk about how to make it performant. I just have these two examples. So your code should also be reliable. Don't catch all the exceptions and let the user know when something goes wrong. So the way to do it is providing always a fallback, like an on-error method. We said it should be lightweight. There are some countries, some developing countries, where internet bandwidth is really expensive, and they might not want to download applications that are really heavy. And there's also a reluctance from developers for adding big libraries. So a person might decide to add a smaller one instead of yours. So the way to do it is checking at runtime whether a library. So in your SDK, you can check at runtime whether a library is there, and if it's there, you can use it. And otherwise, you do it the Android way. And this is a great thing to do, but it's also more work for the user since they need to compile, since they need to provide themselves the library. And another way to be lightweight is just to separate your SDK or your library in several ones. So instead of having a big monolithic SDK, you can separate it in parts. For instance, you can have a Java one, and then you can have an Android one that adds some functionality to it. And then you can have also a specific functionality, a specific feature that not every single app in the world will need to do, or some other. These are just examples that we have at the moment, but for any different SDK would be different things. So here finishes my talk. The takeaway is build things, share them. Try to do libraries. Don't start with the library concept. Just start with writing your code and then try to abstract it. You will end up writing better code, and you will contribute to the community. So if you have any questions, now is the time. Thank you.